Error handling. Let's talk about the general end-to-end error handling workflow in enterprise and distributed API systems. And we will further talk about error logging and distribution, which is usually used for monitoring and logging purposes in enterprise API systems. Before getting onto the subject, that I will be using the same application which I have used to demonstrate Java time in distributed API systems for this implementation. And you can find the Java time link above in this video. Despite using it as a single API, it has been splitted out into two microservices based on its usage and contents, such as trips and cars. And each service will get consumed by different audiences with different frequencies, and they are able to scale independently. So let's get back to the topic. The exceptions are generated by all the layers of your application, especially if you are using MVC application. The data layer, service layer and controller layer will generate their own exceptions like null pointer exceptions, SQL exceptions and maybe transaction exceptions likewise. So what's the big deal about exceptions? Literally speaking, there are two things about it. Let's talk about those. Firstly, it is advantageous if the exceptions are scoped into each layer, so you have a clear boundary between layers, and the other layers do not require to know about the internal exceptions or exception handling of another layer, which also can be identified as a fact that it enhances the cohesion of a particular layer. And each layer should handle exceptions internally and produce a layer specific exception to the subsequent layers. Mainly instead of producing a row general exceptions like null pointers, transaction exceptions. So from the error message, you know that which layer is generating the error. In order to achieve this, what you can do is that wrap the general exceptions with a kind of layer specific exception, including a descriptive message and a defined error code. So the other layers will know what it is all about, the error, and they could handle the exceptions accordingly. Second advantage is that in the event of the layer specific exceptions getting updated, the impact to the subsequent layers are minimal. And importantly, all the error codes of each layer should be available over general documentation, maybe of the organization, for visibility of everyone, including the developers and support teams. For your reference, in this implementation, I mentioned all the error codes in the README section, which you can find in the description section below. So let's dive through details of this particular implementation. So as per this implementation, I have defined DAO exception and service exception as layer specific exceptions. DAO exception is basically encapsulating data access related exceptions into a single class. And the service exception will contain exceptions related to underlying business logic implemented within the service layer. So the service layer will expect only DAO exceptions with exact cause and a particular error code from the data access layer. And the service layer will encapsulate the service exceptions with a necessary error code to the controller. And let's talk more about controllers. Controller will state, I will validate, transform and route. So what does that mean? The controllers are responsible for routing the requests to necessary service methods within the API. And in addition to that, it will ensure that the input values are validated, and it will transform payload into necessary data transform objects, especially what we call as DTOs, which act as a payload contract for each and every API service. And I will demonstrate implementation related to this during the code demo at the end of this video. So upon handling the exception, controllers should not execute the business logic specific workflow, since we have the service layer for that particular purpose. And the controller should send the formatted and descriptive error message to the consumer. Hence the controllers will be much more cleaner and easy to maintain when it is free of exception handling code. So how do we decouple exception handling from controllers? Let's talk about the past and present options provided by Spring framework. So before Spring 3.2, there were two main approaches to achieve this particular purpose. One approach is that we can use handler exception resolver. So this was introduced back in the time when Spring 3.1 was introduced, and it was enabled on dispatcher servlet by default. And one limitation with this was that it doesn't allow to set error details on the body of the response. And on the exception handler, you can annotate methods in a particular controller with exception class or custom exception classes. The main drawback here is that it is active only for the defined controller, and you cannot actually globally define those exception handling. So after Spring 3.2, there are two new reliable approaches are introduced. The first one is controller advice. This is what I have used for this particular implementation. This breaks away the legacy MVC approach and result response entity with your own custom error format, and especially including error code, message, and details of error body, etc. And the second approach is use of response status exception. This comes with Spring 5. So instead of defining custom exception handlers, you can directly use this as a standard template. However, I wanted to have my application specific format with the error codes and descriptions. Hence, I have used my own implementation for this, but if you are willing, you can choose to use this particular implementation. Since I am using controller advice for this implementation, this error message will be used as a standard consumer response for any error generated out from the controller. And apart from the errors, even for the success responses for the services which actually does not have a return, such as the save, update methods, I will share a standard messaging template, and we will see more details in the demo how that success template will look like. Apart from the consumer response, the error has to be collected onto a central system for the purpose of troubleshooting and analytics purposes. And I have used AoP, aspect oriented programming, to achieve this particular purpose within this implementation, and let's just brief about aspect oriented programming. AoP is a pattern to enhance modularity of applications by separating the cross-cutting concerns like logging, security, etc., which actually spans through multiple objects in your program. And there are few concepts used in AoP, such as aspect, which encapsulates the advice, and point cuts, where the advice is known as the activity to be executed at a particular join point. And the join point is actually a point in program like method, field, exception. However, Spring AoP will support only for method join points, and a point cut is something like a particular query to identify a particular join point. You can execute advices at different phases of method execution, like before method execution, after successful execution, maybe throughout the execution of a particular method, and after throwing an exception, and especially after method executed with or without a particular exception. There are two main aspect libraries available, such as Spring provided one and the AspectJ. AspectJ AoP is a full implementation of AoP where it supports for all domain objects in a particular program, and it is executable at all levels such as methods, fields, etc. But AspectJ needs AspectJ compiler, and Spring works actually with the Spring provided compiler. All the aspects transform into executable code, which is known as the weaving process. And there are three types of weaving, such as compile time, post compile, and at the load time. Since I have used the aspects in the code, I will be using the compile time weaving, where the aspect will get compiled into the woven file and it will get available on the application class path, same as the other class files. So let's look at the high level design of this application. So in this implementation, the exception logger will implement around advice to catch the exception and construct this descriptive payload for analytics purpose. And specifically, you can see it has a link to the customer error with the error ID. So when consumer raises a concern about a particular error, it will be easy to find the detailed log from the whatever the logging mechanism that you are having. So this aspect will listen to the specified point cut and publish this message to stream for further processing. And I will not cover the message streaming in this particular demo, but I will be talk about this on another session, maybe with Apache Kafka, that how we can achieve this particular purpose. So talking about the high level architecture, there is a microservice layer and couple of shared services such as the configuration system to manage configuration centrally and update the same without restarting the relevant microservice, and the common code which is reused by all of the microservices is located here. The shared configuration and the code will increase the speed of adding new services since the boilerplate code is reduced and most of the cross-cutting concerns are separated out from the business logic. This is a package interaction, and each package is literally a particular Git repository. The relationship of my fleet cars only shown for this particular purpose, mainly for the clarity, and each microservice will inherit and reuse the underlying infrastructure. Utils and validators are defined as independent jar repositories. All the configuration defined in my fleet configs Git repository. Since configuration is separated from code onto a particular Git repository, you will experience all the pluses provided by the Git, such as versioning, reverting, and branching likewise. So let's go to the machine and see how the implementation looks like. So as you have seen, we have two different services in this example. One is to get cars and the other one is to get trips. So first let's try to retrieve a car record. So this is just after starting up the application, so I don't have any kind of record. Let's see what will be the output. So I'm trying to do a get on this particular car resource. So it gives me this error, entity not found. As you can see, the error is having a specific format. It is having the error ID and it is having an error code, and it is showing the error message entity not found for. It is showing the resource ID and the status plus the timestamp. And especially from the error code, you can identify by which layer this particular error has been introduced. And let's try to search for this particular resource. Since searches are unlike resource identification, I should get an empty array, because for this particular resource ID, especially for the car registration ID, I don't have any record. Let's try to create a new record. So before start that, I have few constraints here. The registration number should be less than 10 and the chassis number should be less than 10, and even the tire data year has to be a particular year, and this capacity should be less than 4000. So before create those records, let's validate those fields. So I'm entering couple of numbers. So I'm getting this error message. So I get the error ID, error code, and the message, status, timestamp, and I'm getting an error array. So on this array, it is showing what is the rejected value and what is a field. So let's say I am doing another change here. Let's say instead of year 2005, I am adding another 0. So this is invalid year. So it is getting added to the payload. So I can violate almost all the constraints here. So they will be getting complained in here. So let's undo all and let's create this record. So it gets successfully created. As I have mentioned to you earlier, like failure messages, for success messages also we do have a particular standard message format. So this is a success message format for the things like create, update sort of, and we'll look at how the class looks like when we are going through the code. Similarly, I will create a trip. On trip, we need to give the car registration number, driver ID, distance, and couple of timestamps, and a trip number. So I'm creating a particular trip. So I'm getting a message, it is successfully created. Let's go ahead and retrieve this particular trip. So I'm searching for this particular car ID C44456. It is the one that I have created, and I'm searching for this particular date range and this particular time zone. So before retrieving, I'm doing some change in time zone. Let's say if we violate the time zone format, let's say I'm adding a number here, then instead of giving the result, it will be saying invalid time zone, search.timezone is wrong. So this is a rejected value. And likewise, if I do any violation on the date, it also will get added. So we can control the requests from the controller itself without going into the application. So let's undo all those, and if I search now, it should give a result like this. It is giving a trip ID, trip number, distance, car registration number, and all the information that we have created. And during the presentation we have talked about, same as the error message given to the user, there is a detailed error message given for logging purposes, which will be sent to particular logging platform through the streams. So I can show that on the log itself, since still we do not have streams integration with this. So this is the message that we are getting on the console. So this is actually for the incorrect time zone and incorrect date. So let's go through the coding related to this. So all the configuration related to the microservices are located within my fleet configs. As you can see, I have the application properties, which is globally applicable for all the microservices, and microservice specific property files also we can maintain in here. So this one is specifically for my fleet car microservice dev profile. So we do have all the database configurations and chassis number length, engine number length, and so on and so forth. And next we have the myfleet config server. So this is where the configuration server is running, and this is the application properties. So in here I need to give the Git repository URI. Since I am running this in the local environment, I am just giving the file path, but in the real environment you need to give the Git host name here, including the port number. Then let's go and see car microservice. On the car microservice, I'll start with the domain classes. This is the domain class of car. So on car I have the registration number, chassis number, color, engine, and car and engine is having actually one-to-one relationship, and car is having multiple number of tires, so it's having one-to-many relationship like this. And if I go to the engine is again having a one-to-one relationship with car, and we need to put JSON ignore to avoid circular calls. And this is a tire object, so it's having ID, number, and year along with the car relationship. So if I go to the DAO, then I have a DAO for car, engine, and tire. I'll quickly go through with the car DAO. So in car DAO we have a search method which accepts the registration number, and get car method which again takes a registration number, and get reference in order to get car object only with the primary key, and save method. Update method you can implement based on your requirement. Remove method is here, but I will be using only save and get methods in here. So as you can see here, I have not added validations for search and get fields because all those values are getting validated at the controller level, and upon saving, the entity validators will validate the entity. Like in car we have size defined for relevant attributes. And you can notice here all the DAO level exceptions are handled, and they are throwing a DAO exception with a particular error code and a message. So further, this message also we can take out from the code onto a property file, and error codes I have mentioned on the readme, and error code definition also shared, and we can find all the shared error codes under myfleet utils. If you go into exception class, it has all the error codes. So it's better to centralize error codes in order to avoid duplication. Let's go to the service layer. This is the car service. This is the interface. I have search, get car, save, update, and remove. And if I go to the implementation, I do have get car. So as you can see here, by calling DAO, I am expecting a DAO exception, and again it is being handled, and it is throwing a service exception to the consumer. So mainly the consumer is a controller, and all the methods are like this. So in here I only need to handle DAO exception when I am calling the DAO layer. For any other exception added by the service layer due to the business logic, then I need to handle that and wrap the error with a service exception. Let's go to the controller. This is a controller. Since we do not have any error handling in the controller is much more cleaner. So it is mainly calling to car service for search, or if we need to get a car, and it is doing the DTO transformation in order to send the output attached to the response entity. And as I have told you earlier, the success response object is here. So things like saving, updating, we do not have any specific output. So we can wrap the output with a success response saying successfully created, and we can attach HTTP status and a timestamp. So if we go to the success response, it should locate within the util project under util responses. So we have success response, it is having a message, status and timestamp. So all those are shared among all the microservices. And let's look at where the controller exceptions are handled. So I have car exception controller defined here, and here I can include any exception added by this car microservice. So for demo purpose, I have added data integrity violation here, and it will generate record already exist. But I have a super type. Super type is the exception controller. So again, all the exception handling I have separated out onto util, and instead of having a util, you of course can have a separate exception repo. So let's go to the super type of this one. So this is a super type. In here I have handled service exception, validation exceptions, constraint violation exception. Likewise, most of the general exceptions are handled here. So on the microservice level, you don't need to handle those exceptions, and for all the microservices it is generally defined in one common place. So if anything is custom for a particular service, then those can be defined here. So as you can see the annotation, it is the controller advice. We can give the path to reduce the scanning cost to easily locate the bean. Next we'll look at the aspect where all the logs are transferred to backend services. So under handler, I have the exception logger that we were talking on the high level design diagram. So I have a log exception. So this is around aspect, and I'm giving the point cut here. Point cuts are separated into point cuts file like this. So I'm looking for general exception controller plus car exception controller handle exception method. So if anything generated out of the handle exception, it will get captured in here. So what I have done here is I have received the stack trace, signature and the API responses which are generated to the user and the error ID, and along with that I create a detailed exception log. So this is what we have seen in the console earlier. And importantly, as you can see, all the error responses are encapsulated into this error response object. So the main purpose is that throughout all the microservices, we can maintain a standard pattern for error messages. Otherwise, when different types of messages are generated from microservices, it will be difficult to maintain. So again, this error response class is also from shared util folder. And the dependencies to the shared repositories should be given in the POM, since I am using Maven as a built-in tool here. So as you can see, for utils, I have given the local path here since I am running this project in my local environment, but in the real environment, POM should be authenticated with the repository manager, and then you can freely add the dependency. So apart from this, I have validators also. I will talk about validators in a separate video. Let's look at the server starting sequence related to this. So this is a console setup. I need to start up this in the local environment. So in here I have the Spring configuration server. So I can start the Spring configuration server like this. And in here in the bottom cell, we have all the Git property configurations. As you can see the trips, all the property files are located in here. And this is where we do have the validators shared library, and this one is for validators utils library. As I have shown you, I have given the file level path to the build location, but in the real environment you can import it from the repository server. So this is my car microservice and this one is for my trips microservice. So I will start the car microservice. See, when it is starting, the configurations are getting loaded related to cars microservice, and this is the starting up of the trip microservice. So this project is available in Bitbucket. So the project is myfleet distributed, and you can see 6 repositories under myfleet distributed project like cars, trips, and the config server and configs. Then we do have utils and validators as external libraries. So if you go into each and every repository, then you will be able to find the setup information, and likewise you need to set up all the project, then you can start this application. I will include more details within the description section of the video. And I hope this video is helpful for you to get an idea about exception handling in enterprise API systems. And let's meet again in another interesting topic like this, and please make sure your post notifications are on. Until then, stay safe.